Now see, example 6.3. Given in figure are examples of some potential energy functions in one dimension. The total energy of the particle is indicated by a cross on the coordinate axis. In each case, specify the region, if any, in which the particle cannot be found for the given energy. Also indicate minimum total energy the particle must have in each case. Think of simple physical contexts for which these potential energy shapes are relevant. Now see here, total energy, that is kinetic energy plus potential energy, that we know. So from this one we can write kinetic energy, that is E minus potential energy. Now kinetic energy half mv square, that should be always positive. Always positive. It never be negative. It implies that here the region in which the kinetic energy is negative, there the particle cannot be found in that region. Okay, so suppose we consider this first graph, this one. This is V0, means potential energy. This is kinetic energy. So here, if x is greater than a, means on this side of the graph, potential energy is greater than total energy. So as per this equation, we can say if potential energy is greater than total energy, then kinetic energy will be negative. If kinetic energy is negative, it implies that particle does not exist in that region, because kinetic energy of the particle, that should be always positive. So here, for x greater than a, in that region, particle will not exist. And minimum total energy, so this can be 0 up to. Okay, then second thing, now this one. So here see, potential energy is again greater than total energy, and in all region up to A, to C, to B, to D and onwards, everywhere here potential energy is greater than total energy. Now again here from this equation we can say, if potential energy is greater than total energy, means kinetic energy will be negative. Never possible. So anywhere here below the graph, particle will not be there. This one. So here, for x less than a, means in this region 0 to a, total energy is less than potential energy, kinetic energy negative. So in this region, particle does not exist. Similarly, for greater than b also, particle does not exist. Okay. Now here the minimum total energy, that can be equal to minus V1. Okay. Then after fourth graph. So here see, suppose we think about this particular region, minus a by 2 to minus b by 2, this much region. So here, this is E, and above it, there is the V0. So minus a by 2 to minus b by 2, in this region, potential energy is greater than total energy. So kinetic will be negative in this region. It implies that particle does not exist in this region. Similarly, on right hand side, plus a by 2 to plus b by 2, particle can't exist. Clear to all of you? And here also the minimum energy, that is minus V1.